Look at the posture of these students. We like to think that humans are naturally curious creatures, but biologically speaking, the brain is not designed for thinking. It is actually designed to save you from having to think, because careful thought is slow, effortful, and unreliable. But we do enjoy mental work when it succeeds. Solving a problem triggers a hit of dopamine in the brain's reward system. People love to solve problems. They just avoid problems that seem unsolvable. If your students are tuning out, it is likely because the cognitive conditions aren't right. Today, we are going to fix that by taking a dry, flat lesson plan and transforming it into a structurally sound cognitive puzzle. Take a moment and pull up a lesson plan you've taught before, something that felt like a grind to get through. We are going to rewrite it right now. Moving forward, your objective shifts toward the architecture of the lesson itself, building an environment where successful thinking becomes the inevitable result. Look at your current lesson plan. You likely have a list of standard learning objectives. Usually, these are just facts you want the students to memorize by the end of the class. Step 1. Reverse engineer those facts. The material you want students to learn is actually the answer to a question. You need to find the core conflict those facts resolve. Instead of listing a passive objective like learn the 3 atomic models, rewrite it as an active mystery. Ask, what is the actual nature of matter, and why did early experiments contradict each other? When you hand someone an answer, the cognitive work is over. When you present them with a well-calibrated question, their brain automatically tries to close the gap. Step 2. Audit the background knowledge. To engage with this new question, what specific facts do your students need to know before you ask it? If they don't already have those foundational facts memorized, you must build a mandatory review sequence into the start of your lesson. Critical thinking requires a baseline of raw material. Without these foundational facts in long-term memory, the brain lacks the components necessary to even begin a mental analysis. Step 3. Identify and mitigate areas in the lesson that cause cognitive overload. This diagram illustrates the flow of human cognition. Your students' working memory is the mental space where they hold and manipulate information. It sits as a highly restricted bottleneck between the massive amount of information in the environment and the vast storage of long-term memory. If you give multi-step instructions or present a complex chain of logic, you rapidly exceed this limited capacity. The ideas quite literally drop out of their heads. Scan your lesson outline for these exact moments. Look for any point where a student has to juggle more than 3 new pieces of information at once. When you find an overload point, create an off-ramp. Move complex instructions, lists of rules, or reference numbers to physical handouts or write them on the board. When students check out during a complex task, it is rarely intentional defiance. Their mental workspace is simply full, and their brain has shut down to avoid the frustration. Step 4. Evaluate the chronological placement of your lesson's primary hook. Take a look at this classic science demonstration. You drop burning paper into a glass bottle and set a hard-boiled egg on top. The flame dies, and the egg gets sucked inside. Instructors often put these moments at the very beginning of class to grab attention. But without the prerequisite knowledge, this acts like a magic trick. It provides a momentary thrill, but the curiosity to understand it fades quickly. To extract the cognitive value, you must adjust the sequence. Establish the baseline facts first. Warm air expands, and cooling air contracts to form a vacuum. Delaying the demonstration until after this factual review forces the brain to apply its recent knowledge. Students move from observation to prediction, using those established facts to explain why the egg moves. This shift in timing converts the experience. A moment of passive awe is replaced by a targeted exercise in scientific analysis. Look back at the document in front of you. You have taken a passive list of things to memorize and structured an active narrative arc. You are verifying background knowledge, introducing essential conflict, offloading the memory management, and timing the challenge for maximum impact. The next step is to teach it. Afterward, write down a few quick notes in a teaching diary to track whether the difficulty level hit the sweet spot, or if the students needed more background facts. When you frame learning as a structured puzzle, you work with human biology. You give your students the exact conditions they need to experience the genuine rush of successful thinking.